So this is just going to be a really quick review on systems, which I don't think you've had a lot of exposure to since Math 1, but it is something that's used in calculus kind of fairly early in the curriculum, and we kind of always stumble over it. So this review will hopefully help us be able to move right past that. So this should bring back some 8th grade, 9th grade fundamentals. So a system is when you have two or more equations, and the goal of the system is to be able to find where the two linear lines, and they don't have to be linear, but most of the time they are, where the two linear lines cross, where they meet each other. So the solution is a point. It's like an x comma y. The most basic way to solve that would be to take these two equations and solve them both for y and graph them, and then find the point on the graph where the two lines cross. That poses some issues. Sometimes when we solve for y, it's not very pretty, and then the majority of us have a really difficult time drawing straight lines and being exact about where our points are. So there are two algebraic ways to solve systems where it doesn't involve graphing, which is wonderful. The first method is called substitution. And that's what we're going to do for the first two examples. So substitution is used when you have a variable, and it could be x or it could be y, that is already completely by itself. So we have that x equals negative 2y minus 2. So I know that x and negative 2y minus 2 are equivalent. They are equal, which means in place of an x, I could put a negative 2y minus 2. So what I'm going to do is down here in this bottom equation, I'm going to take this x and I'm going to substitute what x equals in its place. Because by definition they are equal, that means they are interchangeable. So this bottom equation is going to become 3, and then in place of the x, I'm going to have negative 2y minus 2. Minus 2y equals 10, and now this has helped me tremendously because now I have an equation that has only y's, which means I can solve for y. So I'm going to distribute. I'm going to combine my like terms. I'm going to add the 6, and I'm going to divide. So I now know that y equals negative 2. So the point where the two lines cross is at something negative 2. So now I just need the x value. So it makes sense to go back into this top equation since I'm solving for x and this equation is explicitly in terms of x. I can do x equals negative 2y minus 2, but the thing is now I know what y equals. So I can now plug that y value in for this y. So x equals negative 2 times negative 2 minus 2. It's a lot of 2's. So I now know that x equals 2. So I know that the one solution to that system is at 2, negative 2. That is the only x and y combination. If I were to plug it into the top equation, it would work, and plug it into the bottom equation, it would work. Second example is exactly the same. It's a substitution problem. On this one, the y is the variable that's completely by itself. So I'm going to take what it equals, and I'm going to replace it. I'm going to substitute it in for that y. So I'm going to have 3x minus 3. And then in place of the y, I'm going to put what y equals. And then I'm going to distribute and watch my signs. Combine my like terms. Add the 15 and divide by 9. So I know that this solution meets at 2 something. So now I need the y value. So I'm going to go into this equation that has y equals, because y is what I'm trying to find. And y equals 5 minus 2x, but the kicker now is I know what x is. X is a 2. So I can plug that in. So I now know that y is 1. So I know that those two lines cross at 2, 1. Okay, so that's substitution, and you only do it when you have a variable that is completely by itself. So the question that should be brewing in your mind is, what do I do if I don't have a variable that's by itself? So I'm going to look at this example. I do not have an x equals or a y equals. I could take the top equation and solve it for y very easily. However, that's not always the case. So I'm going to show you how to do what's called elimination, which is honestly the method that we're going to use the most in calculus. Elimination means you want something to eliminate, to cancel. So what I'm going to do is I'm going to multiply the entire top equation and or the entire bottom equation by numbers so that either my x's or my y's will cancel. So if I look at my x's, for them to cancel, they need to be the same number, but they need to be opposite signs. So I could multiply the bottom by a positive 4. And I'm just going to go ahead and walk you through what that would look like. So the top equation is not changing. And the bottom equation, everybody gets multiplied by a 4. And that's why this is legal, because you're sort of just inflating all your numbers by a multiple of 4. Now that I do that, when I add these two equations together, the 8x's completely cancel. Forgot my y. And now I add my equations together. So 1y plus 12y is 13y, and 12 and 40 is 52. And then I divide by 13, and I think that's a 4. So I now have my y value. So now I need my x value. I'm going to go, I don't know, back into the top equation. And remember, I now know that y is 4. So 8x plus, and then in place of the y, I'm now going to put a 4. Subtract the 4, 8x equals 8, so x equals 1. So the point is 1, 4. Okay? So now I'm going to go back and I'm going to show you what you could have done instead of the x's. Let me put that negative back. There we go. So if I wanted my y's to cancel, well, he's a 3y and he's a 1y. So I could multiply him by a 3, that would make them the same, but same doesn't cancel. They have to be the same number and opposite signs, so I'm going to give him a negative. So I'm going to take the top equation, that's going to give me a negative 24x minus 3y equals a negative 36, and then the bottom equation gets nothing, and now my y's cancel. So now I have a negative 26x equals a negative 26, divide by negative 26, and I get x equals 1, which is what I got when I did it the other way. And now that I know that x is 1, I can plug it back into the top equation, or the bottom, doesn't matter, as long as it goes in for the x value. And again, I get the solution 1, 4. So obviously you don't need to do both ways. You pick one. I was just showing you that you could get the x's to eliminate or the y's to eliminate. Obviously we want the easiest one, but if you don't so happen to pick the easiest one, either one will work. Okay, so let's do this one. Now when I look at this one, this sort of has a gift because the two y's, one's positive, one's negative, will already cancel. So I don't have to do anything to make them eliminate. So now I'm ready to just add. So 1x and 3x is 4x, a negative 2 and a 10 is an 8, divide by 4, that's a 2. So x is 2, so 2 plus 2y equals negative 2. If I go back into the top one, 2y equals negative 4, so y equals negative 2. So my point is 2, negative 2. So that's kind of like a gift. So don't panic if that happens. That's just a really nice kind of bonus. Okay, last one. Let's look at this one. So I have a 6 and an 8. You could go all the way up to 48, but you can also go up to a 24. They both go into a 24. With the 3 and the 5, they're going to go to a 15. So I'm going to go with 15 just because the numbers are smaller and it hurts my brain less. So if I'm trying to turn them both into a 15, I'm going to multiply the bottom by a 5. I mean the top by a 5 and the bottom by a 3. That'll make them both a 15. However, they're both a positive 15, and I need one of them to be negative. So I'm going to put a negative on my 5. It does not matter. You could put the negative on the 3. Whatever floats your boat. So negative 30x minus 15y equals negative 30. There are about 1,000 places for you to make a careless mistake in these. So I highly recommend that you slow down. A problem like this, when we integrate it into a calculus problem, again, the solving the system becomes a step in the process, and you don't want to miss a calculus problem because of an algebra mistake. So slow down with your algebra. You're going to be learning the calculus, but you don't want to stumble over your algebra either. So just slow down. Plus 15y equals 36. Those cancel. So negative 6x equals a positive 6. So x equals negative 1. I'm going to go into the top. 6 times negative 1 plus 3y equals 6. So negative 6, add the 6, and divide. So negative 1, 4. So hopefully this was just a really good review on systems. They're going to pop up pretty early in calculus. And like I said, they are just one of the many steps in a particular type of problem. And it's not something that you want to stumble